Now we are taking a general problem. Suppose we want to write Riemann sum formulation for this function here with this integral limit 0 to 8. So we can say our limit is in the interval 0 to 8, like when you compare like a b, so your a is 0 and b is 8. Now this is the function here which is square root of 64 minus x square for f of x. Now we want to write right Riemann sum and left Riemann sum for non-specific value of n. So n is n. So in terms of n, we need to write right Riemann sum and left Riemann sum. Let us see how we do it. First we find delta x. So you know delta x is b minus a over n. So b is 8, a is 0, n is n. So we get 8 over n. This is my delta x. Now when you look at the boundary points, so starting at 0, so we can say that my x0 is 0. So the next boundary will be now 8 over n. This is the one step. The next one will be 2 times 8 over n. Then will be 3 times 8 over n, and it will continue up to 8. Now since we are looking for right Riemann sum, so we'll start from here. So let me write the function. So if we continue in this fashion, then we see our delta x is 8 over n. Now function x1 is 8 over n. So we need to figure out what is f of x1 or f of 8 over n equals. Your function is here, so you can easily see that this will be 64 minus, my x will be replaced by 8 over n squared. So it goes like that. So that value now you plug here, you get square root of 64 minus 8 over n squared plus square root of 64 minus 2 times 8 over n squared, and you continue like that. So I give you the refreshed answer. Finally you can see that it will come out like 8 over n and then multiply it with square root of 64 minus 8 over n squared, and then another will be 64 minus 16 over n squared because 2 times 8, and continues that with the last term will go for x8. So that gives you now 64 minus 8n over n squared. So you are getting like this. Now I'll do this one for left Riemann sum. So left Riemann sum, you know that it will start from 0. So when you starts from 0, so you get just 64 minus 0 squared plus 64 minus 1 times 8. It was 0 times 8. So then you get 8 over n squared. So it will continue. You will not go up to 8n. You will stop at square root of 64 minus 8 times n minus 1 over n squared. And this everything will be squared. So we will be interested in right Riemann sum and will ask further question on this. Now when n approaches infinity, then this Riemann sum approaches to this integral. This integral is nothing but 1/4 of the area of the circle of radius 8, so which is pi r squared, and r is 8. If you look at the function y equals square root of 64 minus x squared, now you square both sides, then radical will be removed, and then add x square both sides. So you get y square plus x square is 64, which is the equation of a circle, center at 0, 0, and radius equals 8. So we have taken our integral from 0 to 8, and we are taking square root sign. That means we are interested to find the area only this portion in the first quadrant. That's why we say that the area will be 1/4 pi r square. My radius is 8, so it will be 8 squared.